Okay, thanks very much for that introduction, Megan. I also love the title of state geologist. I'm about a year and a half into being state geologist, and I love the job. In addition to the strange and fun title of being Massachusetts state geologist. To be clear, there are other geologists all around the state, but I get to be called the state geologist. What that means is it's a designation that exists in 48 out of 50 states, and it means you run the state geological survey. And so part of my motivation in coming today was to tell you a little bit about the State Geological Survey, but I'll keep it focused to coastal work that my colleagues and I are doing. Before I jump in addition to thanking Megan for that nice intro, I feel like it's customary to say, oh, it's tough to come on the heels of all those great talks. The talks were great, but it's actually quite easy to come on the heels of them because Hillary did such an amazing job sort of illustrating the Marsh Trio, which is going to save me time because I don't have to talk about it. And Sarah, thank you so much for introducing Mass Marsh, which I'll talk about. So this is our statewide coordinated salt marsh restoration program. And Wenli, thanks for mentioning the utility of historical aerial imagery, for seeing that berm back in the 1930s that is impacting hydrology today. All of those are going to show echoes in today's talk. So amazing session thus far, but thank you for all the help. I'm the state geologist. I'm showing here a big drumlin at the mouth of the North-South Rivers in Scituate, Mass. I know it's not quite on the Cape, but it's close. And this drumlin's eroding. It's contributing boulders and cobbles to this beach, as well as sand that's making its way down to Hummerock. And then a lot of the fine-grained sediment is moving up into the North-South Rivers estuary, nourishing the marsh. And then some of it's probably also nourishing shellfish habitat in the intertidal and subtidal. So I just love this slide because it illustrates this great biophysical connection between the sort of abiotic drumlins and the biotic environments, and really, of course, salt marshes and tidal flats. These are these wonderful biophysical habitats where the ecology and the geology mix together. Let's see, is this working? Nope. Okay, the pointer works, but not the slide advancer. So my main points for today, I'm going to tell you about Mass Marsh. This is this integrated program across the state. And my point about Mass Marsh is if you work in mass restoration, if you work in salt marsh restoration, Mass Marsh can help you monitor and restore your marshes. There's this amazing community in the state doing this, and we're just one small part. But hopefully I can show you there are some helpful things that can help you on the front end, the execution, and the back end of restoration. The second main point, I'm going to extend beyond our focus on salt marsh restoration, talk a little bit about blue carbon. So this is carbon stored in salt marshes. We'll talk about status and trends across the state, and talk about projects that are happening through the state survey right now to hopefully move the needle and get our marshes to store more carbon. And I'll also talk about sediment. The coast needs it. That's my big point for sediment. It needs sediment. All right, so the first thing, Sarah introduced Mass Marsh. Many folks in this room are on an advisory committee for Mass Marsh, so thank you for your time. This project was started by Mass DEP, and I think it was started out of conversations between communities like this and the regulators saying, yes, we want restoration to move fast. Yes, we recognize the urgency of sea level rise, but we have concerns about where projects are happening, making sure that they're happening in the most essential places, speaking to Sarah's point about is it convenience or is there sort of a framework? So we're trying to help with that framework. And then secondly, how do we know that it's working? Everyone's monitoring these projects in different ways, and if we could standardize the way that folks were doing the projects and monitoring the projects, man, we could move a lot faster as the regulators. And so the work of Mass Marsh falls into three big buckets. The first is status and threats monitoring across the state. So trying to keep an eye on salt marshes across the state and see how are they doing. Of course, that is no easy task, and so I'll talk about how we're doing that. The answer is, as much as possible, using satellite data. So we'll see what can we see from above, but also if people are all collecting data the same way, we can really leverage all those observations that people are already making to paint a holistic picture of what's happening across the state. So the second big bucket is that data curation and coordination. How do we get people to do their monitoring in ways that are similar enough, or ideally sort of all the same way, and then ultimately get all that data into one place where we can digest it? And then last, collaborating with practitioners to try to increase restoration efficacy. So working directly hand in hand with restoration practitioners from the New Hampshire border to the Rhode Island border to see what's working really well, and then developing guidance documents and getting out in the field with people to help it work better. I'm part of a large team. And so my role on this team is sort of the technical lead, and I want to highlight my partner in crime or partner in collaboration, Katie Call. She leads the collaborative aspects of this project. Susie Moser led a great session this morning about how difficult it can be to bring all the people together, but also the opportunity when you do it right. And so Katie is really my leader in developing those ideas and making sure we're working as well as we can in a coordinated fashion. This is just the scientist side of things. And I do want to highlight Dave Burdick at UNH, Mark Carullo at Mass CZM, and Amanda Davis at Mass Division of Marine Fisheries are core team members sort of helping with a lot of these core tasks. So really appreciate having the sort of state engagement as well as Dave, who describes himself as the OG of salt marsh restoration. And I think a lot of people would agree. But I mentioned an advisory committee. Many folks here in the room join us an hour and a half every other month for this project. One thing I forgot to mention is the idea is that this is a long-term project. So we were funded in 2024. We're now about a year and a half in, and the goal is for it to be a roughly 10 to 20 year plus project where we just support and provide coordination in perpetuity and define our mission and make sure we're adjusting as we go along. This group helps us do that, and you'll notice we have representation from the nonprofit sector, from the for-profit engineering and consultants, from national agencies that are helping to fund restoration, as well as state agencies funding restoration. The goal here is to try to get everyone at the table. And if you think you should be at the table, let me know. All right, so what are we actually doing? I mentioned data coordination and standardization. Sarah briefly mentioned that we've developed 3 standard operating procedures for vegetation, hydrology, and elevation. Those are PDFs right now. They say they're up on the Mass Marsh website, which you can see at umass.edu/massmarsh. But our goal ultimately is to make them living, usable tools where you can go out in the marsh with either a field data sheet that you then upload the data sheet and it all gets stored in its database with centralized data protocols and metadata, or you can be out there with your tablet or phone entering the data as you go, and whether that's vegetation quadrats, as you're installing hydrology monitoring equipment, etc. The idea is that everything can be easily accessible from a centralized location. It's a lofty goal. We recognize it's not going to be easy to get there, but we're working towards it. In addition, we can't be everywhere all at once, and so we really want to leverage the power of satellites. So geospatial tools so that everyone here in the room can watch your marsh from space. The idea guiding this is that we're not all going to be remote sensing specialists, but we're providing tools that can allow you to access remote sensing data in a way that really makes you into a specialist. And so this work's being led by Dr. William Spicer through the Mass Geo Survey, and he's developed this portal called massmarshviewer.com. You can also access it through umass.edu/massmarsh. And he's got various report generators and analysis tools that enable you to learn about how is my marsh doing, maybe before you do any action, and then also if you do some sort of restoration intervention, to enable you to help monitor that, not just on the ground, but also see how are things doing from space. How's it doing in the winter? How's it doing at high tide? How's it doing at low tide? How's it doing in places that might not be easy to walk to? So here's some granularity. There's about 15 different things that can happen inside this tool. I don't have time to show all of them, and we should probably simplify it soon. But we're at the part of like throwing spaghetti at the wall and see what sticks. So this is one example. I think it's easy to digest and hopefully highly usable. William has developed a tool to extract every single salt marsh pool in the state. So if you are interested in your property, you can immediately get a sense of what is the percent area covered by pools. And each one represents a potential runnel opportunity. Then how do you decide which one might be the most urgent? So he's tagged each one with the trend of satellite observations over the last 40 years from Landsat to see, is it getting wetter or drier? And if you've got a pool that looks like it's getting a lot wetter over time, it suggests it's growing over time. So I've clicked on this one here in the middle that's outlined in yellow. And down in the bottom left, we're seeing time on the x-axis and pool wetness from satellite on the y-axis. And you can see that upward sloping red line suggests this pool's been getting wetter. We're working on calibrating it so it can be like how much bigger has it been gotten over time. We're not quite there yet. But what we can do, and I want to highlight this is for every single pool, every single ditch. You can look at the resilience trajectory across the state. So here is also within the tool, you can look at historical aerial imagery and then confirm, yes, our satellite imagery is telling a reasonable story. And I can do this all from within the tools. There's historical aerial imagery for the entire state. We can also say, well, after a project's done, is it working well? Now, of course, nothing replaces going out in the field, but as we scale up restoration efforts across the state, we might not be able to get everywhere all at once. Here's an example of a pool that was runneled in 2015, and you can see the slope of that satellite wetness index drops way off after the runnel intervention. Yay, successful project. All right, moving on to blue carbon, changing gears. So I think everyone in the room probably knows blue carbon is carbon stored in marine environments. Salt marshes, coastal wetlands play a disproportionate role in storing this carbon. One tool that the state survey has produced is a map of all the salt marshes in the state, how much carbon is stored in your marsh. It's a GIS layer. You can access it on a viewer. You can access it through the NROC viewer. You can download the data and work with it. We're also looking now at where does salt marsh carbon come from to sort of inform salt marsh carbon accounting. And then if you're not a GIS user, but you just want to know sort of like how much carbon is being stored by my marsh, here we've produced a viewer that you can access online. And I've clicked on that little yellow box down there. The color represents the carbon density of the marsh. And then it'll tell you that little yellow box, that individual property storing 19.7 metric tons of CO2 per year, or about 4.3 cars worth. And this is available for any tax parcel in the Northeast. Now, let's say ultimately down the line, we want to be able to say not just how much is it storing today, but how much more could we store? Well, we have to know what are the net carbon implications of doing restoration. So we're looking into a variety of different restoration methods that Hillary and others talked about today. This is showing another image of ditch remediation, this issue that this practice that Hillary talked about, filling in ditches with thatch, trying to get them to revegetate. Ultimately, what the goal of that is not just revegetation, but also to take a depressed water table, bring it back up to sort of what we call like a Goldilocks level, and this salt marsh peat that was being oxidated and losing carbon to the atmosphere because bugs were eating that carbon with all that oxygen present, bring that water table back up as we revegetate the marsh. We're working on understanding how well is this working to restore carbon to the marsh, and what do you have to do to really maximize that efficacy. All right, final chapter. And I'm done at 2, right? Oh, I don't have till 2. Okay. All right, I thought I was done at 2 p.m. All right, so the last chapter's coastal sediment. I mentioned sediment matters. We had been hearing anecdotes of, you can't do that in this part of the state. It's a really low sediment area. Or you can do this here. There's lots of sediment. And we were like, where are people getting this information from? So we set out to make a map of how much sediment is in the water column. This is another tool that you can access through the State Geological Survey, and I'll share a bunch of links on the last slide. So the left figure is just showing how much sediment is in the water column. It's a 20-year average. So it says on any average, sort of over time, how much sediment's in the water column. Those numbers probably don't mean much to you, somewhere between 3 and 12 milligrams per liter. But on the right, hopefully this is a little bit more interesting. This is the change, the rate of changing suspended sediment. There are some places where sediment is decreasing in the water column and some places where it's increasing. And we know that sediment is important for marsh restoration to work well. And the other thing we know from looking at satellites is that most of the sediment in our coastal water column, it's coming from erosion. A lot of it's coming from erosion of the coast itself. If you look at that satellite image, you see these big plumes of sediment coming off the coast right after a big coastal storm. That first bluff that I showed in that first slide, that's those same bluffs sort of shedding sediment into the coastal zone. In this paper, we've identified all the stable and unstable marshes across the Northeast. And one thing that we see is that south of Boston is where most of our unstable marshes are. that's where we have declining sediment concentrations over the last 20 years. So a really troubling trend that we don't know the answer for, but what we think it has to do with is the more urbanized southern part of New England. We have a lot more coastal armoring. This reduces the rate of coastal erosion. I normally think of erosion as a bad thing, but that erosion is directly contributing sediment to our coastal zone. And so this is sort of our conceptual model. As we reduce the amount of erosion, we reduce the amount of sediment available to marshes, and ultimately the marsh starts to deteriorate. We've summed this up by CZM's coastal resiliency districts across the state. And so the colored bars here represent how much salt marshes in each region need. So you see that big blue colored bar, that's the Great Marsh up in the North Shore. And that marsh needs a lot of sediment. No surprise, it's huge. The gray bar represents how much sediment is being supplied by coastal erosion. And in that area, there's not a lot. So I'm going to circle just the 3 areas of the Cape that are all in deficit. So this south coastal region, I guess that's not quite the Cape, but it's kind of the Cape. Northern Cape and the South Cape are all in deficit. So basically the amount of sediment the marshes need is more than what's being provided by bluff erosion. So in conclusion, we're producing a statewide monitoring and restoration plan with tools that you can use. We're looking at blue carbon across the region and trying to figure out how our intervention projects moving the needle. And then last, we're showing that sediment matters to the coast. All right, sorry for going over.
Awesome job. Not just a couple seconds over. Questions? One question. Yeah, I'm coming.
Thanks, Brian. Could you just go back one slide? I was just curious. Could you say again where the data for those graphs came from?
Yeah, I misunderstood, Chris. I thought I was out of time. So I'll explain these graphs. So the colored bars represent, we've got those statewide or region-wide maps of salt marsh properties. That tells us the density of mineral material in the salt marsh. So it says like for a given plug of salt marsh, here's how much mineral material is in it or sediment. And then we can apply an accumulation rate, which we get from a different data set. If we multiply the amount of sediment in the marsh times a vertical accumulation rate, we get the sediment demand for the marsh. Then the gray bars come from taking old LIDAR and new LIDAR, looking at coastal bluffs, subtracting those two, and you get a volume of bluff that's being lost to the coastal zone. And we consider that sediment being lost from the bluff and dumped into the coastal zone. And so some of these, basically most of the Cape is sediment starved, but no surprise, the outer Cape has a massive sediment surplus. And that's because there's one relatively moderate-sized marsh, Nauset Marsh. Pleasant Bay, I guess, has some marsh as well. But then there's just massive amount, a huge volume of sediment being eroded from the outer Cape, from this region out here, that's helping to nourish the small numbers of marshes there. But it's a real contrast to like Buzzards Bay or Martha's Vineyard Sound, where there's really just not a lot of sediment being provided to the littoral zone, and there's quite a bit of marsh.